Good morning, students. Today we are going to discuss about the Mellin transform of some standard functions. We have to find the Mellin transform of the function, and the function is x raised to lambda integral 0 to infinite u raised to mu f of x upon u gu d. We have to find the Mellin transform of the function x raised to lambda integral 0 to infinite u raised to mu f of x upon u g of u du, where lambda and mu are constants and fp and gp are the Mellin transforms of fx and gx respectively. We have to first find the Mellin transform of the function which is given as x raised to lambda integral 0 to infinite u raised to mu f of x upon u g of u du. Lambda and mu are constants and fp and gp are the Mellin transforms of the function fx and gx. So the solution of the problem, we have to find the Mellin transform of the function x raised to lambda integral 0 to infinite u raised to mu f of x upon u g of u du with respect to p. We have to find the Mellin transform of the function x raised to lambda integral 0 to infinite u raised to mu f of x upon u g of u d. Now by the definition of the Mellin transform, this is equals to integral 0 to infinite x raised to p minus 1 and the Mellin transform of the function x raised to lambda integral 0 to infinite u raised to mu f of x upon u g of u du dx. Here first we integrate it with respect to u and then with respect to x. Now if we change the order of integration, changing the order of integration, then this is equals to integral 0 to infinite. Now first we integrate with respect to x and then with respect to u, so we get it as integral u raised to mu g of u. Now the integration with respect to x is integral 0 to infinite x raised to p plus lambda minus 1 f of x upon u dx and then integrate with respect to u. Now in order to find the integral, we put if x upon u is equals to t, that is x is equals to ut and dx is equals to u dt, then we get this is equals to integral 0 to infinite u raised to mu g of u. Now the limits is same, integral 0 to infinite x raised to x, that is ut, so ut raised to p plus lambda minus 1 f of x upon u, that is t, dx, that is u dt, and then with respect to u. Solving this, we get it as integral 0 to infinite u raised to mu plus p plus lambda plus 1 minus 1 zu multiplied by integral 0 to infinite t raised to p plus lambda minus 1 ft dt and then integrate with respect to u. As we see that the integral in the parenthesis is the Mellin transform of the function fx. So we get it as the Mellin transform of the function fx or ft. So this is fx with respect to parameter p plus lambda multiplied by integral 0 to infinite u raised to mu plus lambda plus p plus 1 minus 1 into zu du. As we see that the integral is the Mellin transform of the function zu with respect to parameter mu plus lambda plus p plus 1. So we get the result is a Mellin transform of fx with respect to parameter p plus lambda multiplied by the Mellin transform of the function gx with respect to parameter 1 plus mu plus lambda plus p, or we can write it as this is equals to, as the Mellin transform of the function is fp. So this is f and p is parameter p plus lambda. So this is f of p plus lambda, and this is the Mellin transform of the function gx, that is gp. So this is g and the parameter is 1 plus mu plus lambda plus p, which is the required result. So the Mellin transform of the given function x raised to lambda integral 0 to infinite u raised to mu f of x upon u zu du is equals to f of p plus lambda multiplied by z of 1 plus mu plus lambda plus p. Now if we take some special cases, case first, if we take lambda is equals to 0, then the Mellin transform of x raised to lambda remains with integral 0 to infinite u raised to mu f of x upon u z of u du with respect to p. This is equals to, when lambda is equals to 0, the result is f of p multiplied by z of 1 plus mu plus p, which is the required. Now case second, when mu is equals to 0 and lambda is also equals to 0, then we get the result as the Mellin transform of the function integral 0 to infinite f of x upon u z of u du with respect to p is equals to f of p into z of 1 plus p. This is a particular case second. Now one important case is when case third, when lambda is equals to 0 and mu is equals to minus 1. This is an important case. When lambda is equals to 0 and mu is equals to minus 1, then we get Mellin transform of the function integral 0 to infinite f of x upon u z of u upon u du. This is the Mellin transform of the function, that if lambda is equals to 0 and mu is equals to minus 1, then we get f of x upon u zu upon u du with respect to parameter p. This is equals to f of p into z of p. If we take the inverse transformation on both the sides, inverse Mellin transform on the both the sides, then we get, taking inverse Mellin transform, we get an important result, which is Mellin inverse fp into zp with respect to x. So this is equals to integral 0 to infinite f of x upon u zu upon U D. This important result is used in the inverse Mellin transform, which is of a great importance. So in this manner we can find the Mellin transform of some important functions which is given in this form. Thank you very much.